Hello students, I'm really happy to see you in this video lecture on the course group U18Pcit701, course name Wireless Networks. And I'm D.Rukmani, Assistant Professor in the Department of Information Technology, working in Bharat Institute of Higher Education and Research, going to deliver you the video lecture on the topic Mobile Network Layer. Mobile network layer, here we are going to see about the introduction about the mobile IP, that is the internet protocol, and the IP packet deliveries, IP agent discoveries, tunneling and encapsulation, IPv6, that is network layer in the internet, mobile IP session initiation protocol, mobile ad hoc network. Under the mobile ad hoc network, we are going to see about the routing, the destination sequence distance vector. At a class, we are going to see about the IoT COAP. So these are the topics we are going to see under the mobile network layer. Now we are going to see about the motivation for the mobile IP. The mobile IP, which is a protocol used to allow the inter-network mobility for wireless node without changing their IP address. The routing is mainly based on IP destination address. Network prefix, example 129.13.42, which determines the physical subnet. The change of physical subnet, that is a change of IP address, to have a topological correct address, that is a standard IP. The solution is, which is a temporary change routing table entries for the mobile host. The problem here is, does not scale if many mobile hosts or frequent location changes. The solution is we need to change the mobile host IP address. So for that, we need to adjust the host IP address depending on the current location. The DNS update takes too long time. All the TCP connections will break. So these are the motivations which comes under the mobile IP. The requirements to mobile IP, which is the transparency, compatibility, security, efficiency, and scalability. The first is the transparency. The mobile end system will keep the IP address. So here it will be having a continuous service after the link instructions. The point of connection to the fixed networks that can be changed. Next, the compatibility. No changes to the current host, OS, or the routers. The mobile end systems can communicate with the fixed systems. Next will be the security. Here the authentications of all the registration messages, efficiency and scalability. Here we'll be having only few additional messages to the mobile systems that will be having a low bandwidth. Next will be the global support for a large number of mobile systems. So these are the requirements which comes under the mobile IP. First is the transparency, and second will be the compatibility, and third will be the security, at last will be the efficiency and scalability. Next, the entities and terminologies which comes under the mobile IP are the mobile node, which is termed as MN, home agent, which is termed as HA, foreign agent, which is termed as FA, care of address, which is COA, at last will be the correspondent node, which is CN. So the mobile node, the entities and terminologies of the mobile node MN are the laptops, PDAs, etc. that we know about. Next, the home agent, that is HA, router in the home network of the mobile node, which helps in forwarding, which registers the current MN location. It tunnels the IP datagram to COA, that is a pair of address. Next will be the foreign agent, that is FA, the router in the current foreign networks of MN. Next, it forwards the tunneled datagrams to the MN. Next is the care of address, COE. The address of the current channel endpoint for the mobile node are the FA or MN. It can be chosen, example, via the DHCP. Next will be the correspondent node, which is CN. Here the node that wants to communicate with the mobile node. So these are the entities and terminologies which comes under the mobile IP. Next, which is an example network for the mobile IP. So here we'll be having a home network and a network connection, which is connected to the foreign agent via the mobile node. Next, the home agent will be having a corresponding network. Next, it will be having the router as the end systems. So see here, the HA, which is a home network. From the home network, it is connected to the internet via a FA, which is a foreign agent, that is a mobile end systems with the mobile node. Next, from the internet, it goes to the router. The router will be having a correspondent node, that is an end node. So this is a sample network diagram for the mobile IP. Hence the overview of packet delivery, that is a mobile node. So here, the first node will be the, see the diagram, the first will be the correspondent node. So from the correspondent node, it goes to the router, and from the router, with the help of the internet, it goes to router 3 or the router 2. If it goes to router 2, then it goes to the home network agent. Otherwise, if it goes to the router 3, means it goes to the mobile node. So this is called the overview of packet delivery. So see here, the upper diagram will be having a CN, that is a correspondent node router, as well as the internet. From that, we'll be having a router to the care of address, and the care of address, with the help of the internet, it goes to the router. At last, it goes to the MN, which is a mobile node. The packet routing procedures. Here, the sender will send the IP address of mobile node, but here the HA, that is a home agent, intercepts packet. The home agent will tunnel the packet to COA by the encapsulation, which is a pair of address by the encapsulation. The forward agent will forward the packets to the mobile. The reverse, here the sender sends to the IP address of the receiver, then the FA is a default router. So the routing, the packet routing process comes under 4 steps. The first is the agent discovery, that is an agent advertisement or the agent solicitation. Next is registration. The third will be the tunneling and encapsulation. And the last will be the routing optimization. So these are the steps which comes under the packet routing process. The first will be the agent discovery. The second will be the registration. The third is the tunneling and encapsulation. And the last step is the routing optimizations. And we are going to see each one in detail. The first is the agent advertisement. So here the home agent and the foreign agent will advertise their presence periodically using an AA message. So these advertisement message, that is ICMP, which is a beacon broadcast into the subnet. So here we'll be having a characteristics of agents. They are the bit HA and F will denote the agent offers the services of the link. Next, the bit M and G will specify the methods of encapsulations. So M, which is minimum, G means which is generic. So here the B represents the agent is busy. T will represent the reverse tunneling. So these are the characteristics of agent which comes under the agent advertisements. Next, which is a packet diagram, a frame format for agent advertisement message. So here we'll be having a type which is equals to 9 and the code length. Next, at last we'll be having a checksum. So under that we'll be having a number address entry size, and the line time of this advertisement. Next, it is followed by the router address 1, preference level, router address 2, preference level 2. And next, we'll be having a type is equals to 16. Instead of code, we'll be having a length, and instead of checksum, here we'll be having a sequence hash. Below that, we'll be having a registration lifetime. This is followed by R, P, H, F, M, G, V. So here R, which is a router, B means busy, H a home agent, F is a foreign, and M, G, V. At last it will be as RSD. So under that we'll be having a care of address 1, a care of address 2, followed by type 19, followed by the length, which is followed by the prefix 1 and prefix 2. So this is a packet format for the agent advertisement message. So if no agent advertisements are present, then the NMAN sends the AS. The NMAN can send out a maximum of 3 solicitations, 1 per second. Next, move the detection using lifetimes. When the mobile node fails to an advertisement from the foreign node with the specified lifetime, then the home agent waits for AA or it will send AS. Next, we are going to see about the registration. So to inform the current location of MN to HA, the registration process begins. So here we will get a COA from the forwarding agent and it informs the HA of its current COA. Next, the third step, it will be renewing the registrations with the FA. At last, it will be registered when it comes back to home. So this is a diagrammatic representation of the registration request and the reply. So first we'll be having a mobile node followed by the foreign agent and the home agent. The first step, the mobile node will send a registration request to the foreign agent. The foreign agent will in turn send a request to the home agent, that is a registration request. So after reaching the home agent will reply for that registration request and the reply will send again from foreign agent to the mobile node. This is for the registration request. The registration reply, the MN to HA. So from MN, the registration request will be sent to HA. From HA, after receiving the request, it will reply to MN that it has received that node. Next, the registration request message and the registration reply message. So in the registration request message, we'll be having 0 to 7, next 8 to 15, next 13, 16 to 23, and 24 to 31. So 0 to 7, which is a type 1, and 8 to 15 here we'll be having an S, B, D, M, G, R, T, X, and from 16 to 31 we'll be having a lifetime. So below that we'll be having a home address, next the home agent, followed by the COA, identification, at last we'll be having the extensions. Whereas in registration reply message, which is a type 3, and instead of 8 to 15, here we'll be having a codes followed by the lifetimes. So which is followed by the home address, home agent. So in reply stage, we don't have COA, that is the care of address. After coming from the home address, it reaches the home agent, makes the identification, at last it reaches the extensions. So the type set is equals to 1 for a registration request. The lifetime will denote the validity of the registration in seconds. P bit will indicate the broadcast package which has been received by the HA in the home network. P bit will indicate this behavior of MN. Its M and G will denote the use of minimal encapsulation or a genetic routing encapsulation. The T will denote the reverse tunneling, that is R and X are sent to zeros. Home address is a fixed IP address of the mobile node. The home agent, which is an IP address of the HA, which is followed by COA, will represent the tunnel endpoint. The 64-bit identification is generated by the mobile node to identify a request and it will match with the registration replies. At last, it makes the extensions which contain the parameters for the authentications. Next, the third step, which is the tunneling and the encapsulation. So the tunneling will establish a virtual pipe for data packets between the tunnel entry and the tunnel endpoint. The encapsulation, which is a mechanism of taking a packet consisting of packet header and the data, and at last we'll be putting it into the data part of a new packet. Next is the decapsulation. Here the reverse operation, taking a packet out of the data part of another packet. The encapsulation methods, there are 3 encapsulation methods. The first is the IP in IP encapsulation, followed by the minimal encapsulation. At last will be the generic routing encapsulations. First is the IP in IP encapsulation, which is a tunnel between a HA and COA. So here the home agent will take the original packet with the mobile node as a destination and it puts into the data part of a new packet and it sets the new IP address. If the packet is routed to COA, that is a care of address, the new header is called the outer header. The inner header, which can be identical to the original headers. So this is a frame format for the IP in IP encapsulations. So here we'll be having a original IP header followed by the original data. So below that we'll be having a new IP header followed by the new data. At last we'll be having the outer header which contains the inner header and the original data. Next, it is the data format for the IP and IP encapsulations. So here it contains the version IHL, which is an internet header length, followed by the DS toss, which is used to copy from the inner head. At last, it is followed by the length. PTL, which is a time to live, which must be high here. DS toss is just copied from the inner head point. IP in IP, which is used in the IP payload, the field size is set to 4. IP address of HA, which tunnels entry as a source address, and COA, which tunnels the exit point as the destination address. The second type, which is the minimal encapsulation. So it avoids the duplication of the identical fields, and it is an optional encapsulation method for mobile IP. The inner header is different in minimal encapsulation. The tunnel entry point and the end point are specified. The type of the following protocol and the address of the MNs are needed. If the S bit is equals to 1, then the original sender address of the CN is included. So this is the frame format for the minimal encapsulation. So here we'll be having a version IHL followed by the DOS length. So below that we'll be having an IP identification, flags, fragment, offset, followed by the TTL minimum encapsulation IP checksum. So under that we'll be having an IP address of HA, care of address of COA. So these are the things which comes under the minimal encapsulation. The last will be the generic routing encapsulation, which is GRE. The IP in IP encapsulation and the minimal encapsulation works only for IP, whereas the GRE, which is a generic routing encapsulation, will support other network layer protocols in addition to the IP. So it allows the encapsulation of packets of more than one protocol suite into the payload portion of the packet of another protocol suite. So the packet of one protocol suite with the original packet header and the data is given, and the new GRE header is appended. So together this form the new data part of the new packet. Finally, the reader of the second protocol suite is put in fourth. So here we'll be having our original header and the original data, followed by the outer header, new header. At last we'll be having a GRE header. At last we'll be having a new data under the new headers. So this is what the generic routing encapsulations. So this is a frame format. So here we will be having the same cut of the IP in IP and the routing. Here the version IHL DS length, followed by the IP identification, flags, fragment, offset, TTL GRE, which is a generic routing environment, followed by the IP address of HV, care of address of COA, which is then followed by the checksum option and the offset, which is also optional. So which is followed by the key sequence numbers on the routings. So these are the key structures which comes under the generic routing encapsulations. So here the GRE header uses only 4 bytes. The C bit will indicate the checksum field which is present and it contains the valid information. R bit will indicate the offset and the routing fields are present and it contains the valid information. Next, the checksum field which is valid only if the C is set. Offset field is valid only if the R is set. Key field which may be used for the authentication. If this field is present, the K bit is set. The sequence number bit, it indicates if the sequence number field is present. If the S bit is set. Recursion control field, which is REC, recursion control field, which is important field that additionally discusses the GRE from IP in IP as well as the minimal encapsulations, followed by the reserved fields and the version fields. So the reserved field must be 0 and or integrated on the receptions, whereas the version field contains 0 for the GRE version. Next, at last we'll be having a routing optimization. So under the routing optimization, we have 2 types, that is a triangular routing and the route optimization. So inside the triangular routing, the sender will send all packets via the HA to MN. The triangular routes longer, higher latency and network load. Whereas the route optimization, here the CN will learn the current location of MN via the HA. So it will forward its packets directly without the HA. So here the CN will create the routing table which has the information about the MN. So the protocols needs 4 messages, which is a binding request, binding update, binding acknowledgement, binding warning. So the binding request here, the correspondent node will send the binding request about the current location of the MN to the HA. Next, the binding update. So it contains MN IP address plus the COA. Third, which is a binding acknowledgement, which is CN if replied to HA. Last is the binding warning. After the decapsulating packet, if the MN is not having the current location of MA, then CA will send the warning message. So this is a frame format for the CN, HA, FA, old, FA, new, and the MN. So here the data is sent from CN to HA. From there, the data is sent to FA old. From FA old to FA new through the mobile nodes. So it will receive an acknowledgement. It will update the HA from CA. Next, for that acknowledgement, for that update, the CN will acknowledge the HA and it will again sends the data to the FA old. From there, it goes to the FA new. For that, the MN changes the location, that is a registration done from MN to FA new. From there, the updation will be occurred in FA old. So as a result, the acknowledgement will be sending back to the FA new and the data will be sending back from CN to FA old to FA new, and FA new to MN. So this is what the routing optimization. One is the triangular routing and another is the route optimization. Case 1, which is a routing directly. So here the CN will send the request to HA about the current location of MN. So HA will send the update message for about MN to CN. The CN will send the acknowledgement to HA. The CA will send the directly to FA old, forward the data to MN. Next, the case 2, which is the routing handover. So here the MN changes its location and register under the new FA. So the FA new will inform the FA old about the new generation of MN by sending the update. So the FA old will reply the acknowledgement to FA, etc. So the correspondent node which does not know about the new location, it still sends the data to the FA old. So that FA old forward the data to the FA and it will send the warning message to CN. Case 3, which is a routing. So here the CN will send the request to HA about the new location of the MN. So whereas the HA will send the update message about the MN to CN. Next is the CN will send the acknowledgement to HA and CN will send the data directly to FA new or the forward data to the MN. So this is what the cases which comes about the routing optimization. So the routing, which is directly routing handover, routing. At last, we are going to see about the reverse tunneling. So here the MN can directly send its packets to the correspondent node. The MN can request a reverse tunnel between a FA and its HA. So see here we'll be having a home network HA followed by the network. From there it goes to the receiver, or otherwise if it reaches the HA, it goes straight to the foreign network. That is, the MN will send to FA. FA tunnels the packets to HA by encapsulation. At last, the HA will forward the packet to the receiver, which is a standard case. Next, IPv6. The problems with IPv6, which is the security. That is, FA typically belongs to another organization. The authentication with the FA problematic. The patent and export restrictions. Firewalls filters based on IP address. The FA will encapsulate the packets from MN. Home firewalls rejects the packets from MN, that is, unless reverse tunneling. The MN can no longer send the packets back to the home network, which is QoS, which is a quality of service, etc. IPv6 introduction, which is a next generation network protocol to restore the current IP and simplifies the protocols. So here the COE can be assigned via the auto propagation, that is BIHER, which is one candidate by the every node. So here the MN can signal a sender directly the COE without HA. M1 will send the new COA to its old router. The old router encapsulates all the packets to M1, forward them to the new COA. Authentication is always granted. The IP address size is 128 bits. The IP set provides the solid security for the communication. Checksum field is not available for the IPv6. So this is a header format. We'll be having a version, traffic class, followed by the flow label. This is then followed by the payload length, next header, hop limit. At last, we'll be having a 128-bit source address and the 128-bit destination address. Mobile IP will exhibit several problems regarding the duration of the handover and the scalability of the registration procedures. So here the large number of mobile devices charging. First is the IP micro mobility support, which is efficient and the low handover inside the protein camp without involving a mobile host. So efficient local handover inside the foreign domain without involving a HA. It also reduces the control traffic on backbone, especially needed for quiet optimizations. The examples for the approaches are the cellular IP, Hawaii, hierarchical mobile IP, that is HMIP. Now first is the cellular IP. So it provides a local handover without renewing the registration by installing a single cellular IP gateway for each domain. So in cellular IP domain, all the nodes should collect the routing information from SIP-GW. The soft handover are achieved by allowing the simultaneous forward of packets destined for a mobile node along the multiple paths. The mobile node moving between the adjacent cells, that is temporarily be able to receive the packets via both the old as well as the new base stations. So the cellular IP will query changes to the basic model IP and it's non-transparent to existing systems. The foreign network routing tables are changed based on the messages sent by the mobile phones. So these should be trusted blindly even if they have been authenticated. So this could be exploited by the systems in the foreign network. Next, the operations, which is the, here we'll be having an internet, that is the mobile IP goes to the SIP gateway. From there it goes to many nodes, that is base stations. So the two base stations are connected to a single node, which we'll be having a data or control packets from M1 or the packets from M12 to M11. So here the SIP node maintains the routing entries. Multiple entries are possible. The routing entry updated based on the update packets sent by the M1. Next is the gateway. So here the mobile IP will channel the endpoints and here we'll be having an international registration processing. The advantages, which is a manageability, multi-path forwarding, efficiency and transparency. Next is the Hawaii, which is a handoff-aware wireless access internet infrastructure. So which keeps a micro mobility support as transparent as possible for both HA and M1. So it does not replace the IP, but it works better than IP. So here each station will maintain the routing cache to deal with the mobility as well as the hop-up TX of packets. I support two types of handovers, which is a multicast group or the page request reach all stations. Next will be the step Hawaii, which is here we'll be having an internet gateway. From there we'll be having a backbone router. From there it goes to the class over router. From there it moves to base stations, several base stations. Or it again goes to the mobile node and it receives the mobile node and it goes to the base station and it will receive the base station. At last we'll be getting the DHCP. So this is what the Hawaii, it is a handoff-aware wireless access internet infrastructures. It's the advantages and disadvantages of voice, which is a security and transparency, whereas the disadvantages is security and the implementations. Next, the hierarchical mobile IP, which is HMIP. So it will provide a mobile mobility support by installing a mobility anchor point, that is MAP. Mobility anchor point, which is responsible for certain domains and it acts as a local HA within this domain for the visiting MNs. So here the MAP will receive all the packets on behalf of the mobile node and it will also encapsulate and forward them directly to the mobile nodes current address. So this is what the here we'll be having an internet fetch. From there it goes to the MAP. So there it goes to the AR, or it goes to straight to from M1 to MAP through the LCA, that is a care of address. Advantages and disadvantages, which is security and efficiency, whereas the disadvantages is transparency and security. DHCP, which is a dynamic host configuration protocol, which is simply used to simplify the installation and maintenance of the network computers. So capability of automatically locate the reusable network address. So it enables the automatic integration of system into an intranet or the internet that can be used to acquire the COA for the mobile IP. So this is a client initialization via the DHCP. So here we'll be having a server 1 and 2, and under that we'll be having a client. So it will determine the configurations. So from there, the client will initialize and it will send the DHCP discover to the server 1 and server 2. From there, the DHCP offers the collection of replies and it will determine the configuration. So after collecting the selection of configuration, we'll be having a DHCP request and the DHCP request options, that is used for confirmation of the configurations. So from there, it goes to the initialization completed. At last, it moves from current initialization, that is a release, DHCP release, which goes to the server which is selected. So these are the things: DHCP discover, offer, request, acknowledgement, and the release. So this is a mobile IP session initiation protocols. So if an application layer protocol for creating, modifying, and terminating sessions with one or more participants. Very simple protocol that has a limited set of commands can read it. The SIP entities, which is a user agent server, proxy server, redirect server, across the registration server. So this is the SIP request response. Next is the SIP request response. Here we'll be having an invite, acknowledgement, buy, cancel, option, register. It's the mandate introduction. So here we'll be having a direct transmission as well as the multi-hop transmission. So the direct transmission, which goes from A to B, whereas the multi-hop transmission, it moves A to B. We'll be having a several transmission: A to C, C to D, D to E, at last from E to B. So it is an infrastructureless dynamic multi-hop network. It does not have a definite topologies. The characteristics are the dynamic topologies, bandwidth constraint, variable capacity links, energy constrained operation. At last, we'll be having a limited physical security.